Again, I will be talking about the biogas production from anaerobic pretreatment of municipal wastewater, which is come with a combination with mixed with some food industry. And I guess you are familiar with many case studies, real case studies similar to this situation where illegally food and agro-industrial wastewater comes in a contact with domestic wastewater. And this is what's happened here in Israel, in the Mediterranean in general, and in other many places in the world as well. So in this project, in this initiative of Ultimate, we together with the Mekorot company, which is the national water, the Israeli national water company, with Agrobics and Greener Than Green from Greece, Agrobics from Israel, spin off the Galilee Society, working together to actually offer a technology that can overcome this issue while looking at the main good resources in the wastewater from both in general, from the organic matter as biogas to convert it to biogas, and from the olive meal wastewater. In this case study, this is the example of the agro-industrial wastewater to produce or to recover polyphenol. About this and antioxidant, about this, Dimitri will be giving some insight about this issue. The Galilee Society is the leading partner of this case study. But before that, I would like to give you some overview about anaerobic in general, anaerobic reactors, and mainly high-rate anaerobic systems, not the story. In general, anaerobic systems or anaerobic process is very, very, very old process. We can see here long time till early mid-90s. Actually, most of the systems were based on slow system, mixed system, or even batch-based systems. But from the mid-90s, people start looking at the contact processes and mainly continuous processes, which we can call it high-rate anaerobic system. And high-rate means a higher flow rate, means a lower volume. And anaerobic is known, that is part of the game of circular economy, because we take a waste and we actually, unlike the linear economy, we recirculate this, we reuse this as a biogas, produce it, and we can use it for heat, for electricity, and so on. It depends if we can upgrade it, so it could be reach a quality similar to natural gas and can be injected in the grid and used. The bioreactor also, we can also produce different materials from organic waste, organic products, but we are not going to talk about this. We will be talking about extraction of polyphenol, because specifically we have this olive meal wastewater, which is rich in polyphenols as antioxidant, high value material. I will make this story, this long story short. This issue started in the 60s, actually, with this guy, Perry McCarthy from Stanford, who the first one to look at the biological processes from the eyes of engineer, when he started put numbers. And this, what we called anaerobic waste treatment fundamentals. And this is make the change from the 50s, 60s, when people start looking at this from the point of view of engineers. We can see that the relative capacity from one, which means high volume, we could reach over 75 when we combine with anaerobic membrane. It's, including, in the way mixing systems, upflow, fixed system, biofilters, and USB non-system, the upflow anaerobic sludgy blanket, the exp system, and so on, that many of these systems were actually developed and improved in mainly in the Netherlands by Littinger Group, and also in the States by McCarthy and other people. And it means that the volume, you can reach the same efficiency with a 75 times less in volume. This is the meaning of the 75. And this is a huge work. Within this project, actually within or even before, we start working with trying to overcome many problems with domestic wastewater. because once we see all of these results, we say, okay, it's okay, everything is fine. Why we are not going and running to apply? Because we still have a lot of problems with anaerobic when we approach domestic wastewater. For this reason, we developed within a previous project, a fixed form based system where actually we can fix the microorganisms. I'm not going to tell you and to get in the technology, but this technology increase the stability of the system. One of the problem with this system is the instability. They are unstable. And then within this project, we, after improving the stability of the system for domestic wastewater, we try to look at Karmiel. We have in this project, by the way, 2 case studies, but today we're talking about the first case study, which is Karmiel system, where we look at the entire system of the wastewater, the Karmiel wastewater. We will apply the AET. This is the technology that I showed previously. It's called advanced anaerobic treatment based on the fixed matrix of microorganisms that make it more stable to produce biogas. At the same time, since this system is very stable, we can also put in olive meal wastewater and treat both, increase the biogas and so on. But this is not the only thing, because the polyphenol is a valuable material and the olive meal wastewater is rich in polyphenols. Then we will try first to recover the polyphenols prior to mixing this with the wastewater, because it's waste of time, a waste of money, and it's good to have it. And about this, Dimitri will be talking. So here I try to shorten. Yeah, okay. So what I skipped some slides. What we have here is olive meal wastewater will be mixed with domestic wastewater, go through the advanced anaerobic treatment system to increase the recovery or the production of biogas. At the same time, we will be using what we call the pack resin, a bead that developed by Greener Than Green, to recover polyphenols. And we get 2 advantages. One, that polyphenol, which considered as a inhibitory compound of anaerobic or biological processes in general, is reduced. Then we can increase the ratio of mixing, the ratio of water. And secondly, we recover the polyphenol as a valuable material. We already got some results from the summertime before we use the technology of Greener Than Green, showing that the system is stable. Briefly, I'm not going to get in details in all of these figures, but if we focus on the 4th one in the bottom side, right side, we can see the biogas that we have almost twice the amount of biogas, twice amount of produced biogas when we put olive meal wastewater. So the first goal actually was achieved, and then we're waiting to see how we can use the recovered polyphenol or the technology of polyphenol recovery to increase this even further. And for this, actually, I give the podium to my colleague, my partner, Dimitri, to talk about the polyphenol issue. Dimitri.
Thank you, Sam. Thank you. Thank you for the invitation. My name is Dimitri Iossifidis. I'm the CEO of Greener Than Green Technologies. Let's have a look at the removal of polyphenols from wastewater stream. The reason behind the removal, as Sam mentioned, is the fact that polyphenols have antibacterial properties and they reduce the yield of biogas production. Moreover, after the removal, these polyphenols can be reclaimed, purified, and can be commercially exploited, as they have a very high market value, sometimes reaching up to, especially for olive oil, 1,000 to 7,000 euros per gram. So we employ solids to absorb where polyphenols are selectively absorbed on through a series of static tests. Static means constant quantity of solid material comes into contact with a constant volume of wastewater. We determine the maximum absorptive capacity of the solid and the time needed to complete the absorption. This gives us the necessary information to determine the most suitable material for a given wastewater. Through a series of dynamic tests where wastewater continuously flows through a packed bed of solid material, we determine the volume that can be treated per kilogram of resin. And we can determine the relationship between contact time and flow rate. This allows us to scale up the experiment from the lab to an industrial scale. In terms of results for olive oil wastewater, we have determined that we can treat about 1.7 cubic meters of wastewater with 1 kilogram of solid material, and removing 23 grams of polyphenols per kilogram of solid. This means that we have achieved a 90% removal of polyphenols, and we expect to have a recovery yield of 60 to 8% overall. Next slide, please, Sam. But why are we doing this? Allow me to take a step back and look at the bigger picture and explain our approach to circular usage of water and resources in a given process and the value this brings to a business. First of all, we examine the process's quantifiable characteristics. Then we look at the quality characteristics of the wastewater produced, but we also investigate the presence of value-added compounds, as Anne mentioned earlier, both in the wastewater stream, but also in the solids, the solid waste produced in the process. Value-added compounds are natural chemical entities of high interest as a result of their properties, biological activity, health benefiting properties, and so on, and the resulting market price, which there are cases reaching hundreds of thousands of euros per gram. I know it sounds crazy. Then we go on to design methods for extracting those value-added compounds from wastewater and the solids, and we look into ways of exploiting what's left of the solids after the extraction. Both these that can be used back in the industrial process as a resource, or they can be commercially exploited as they are, or transforming them into a whole new product. Then we look at the water demand, both of the industry, but also the nearby stakeholders. These can be other industries or farms nearby. And we design a wastewater treatment method to reclaim usable water that is fit for the purpose. Next slide, Sam. Now, fine-tuning such a system can be a daunting task. To simplify matters, we propose an artificial intelligence enhanced decision support platform. This employs machine learning to minimize the need for specialized personnel, and in fact, it minimizes human intervention altogether. This platform interrogates the industrial and wastewater treatment processes, giving and receiving information, and along with the input from users or external data such as weather forecast, historical weather data, soil moisture, and other external sensors, and it can predict the best usage of the water to use it internally or make it available to others. Moreover, it can fine-tune wastewater treatment and even optimize the conditions, the industrial conditions, to produce suitable wastewater of suitable quality, let's say. Next slide, please, Sam. Finally, through this process, we acquire a lot of valuable information. Through studying these processes, the industrial process, the wastewater treatment, and the decision support platform information, the extraction of value-added compounds, both from the wastewater and the solids. And we can use this information, we can apply to this data a lean methodology to reduce waste in terms of material, in terms of energy, process time, or even human hours. But also we can apply circular economy principles and circular economy thinking to transform a business into a financially sustainable and resource-conscious entity, but also build a long-term business resilience as well as improve the social environmental consciousness and image of the company. Issam, back to you. Thank you.
Thank you, Dimitri. So actually, this is the last part of the presentation, and I would like to thank you for your attention. I hope that we make it in 15 minutes as planned. And yeah, the people, this is the list of the people who are behind this project from the 4 partners. Galilei Society, which is the biggest one here because we are leading this project, Agrobics, Mukorot Company, and Greener Than Green. Thank you once again, and if there is a question, we both happy to answer.
Thank you very much, Issam and Dimitri. It's quite interesting for us to see the developments in a country like Israel, where the water is really having a high value. And I may say that in Romania, we didn't value the water in the way that I wanted, but maybe I'm on the wrong path here. But we will learn from you, and really it's interesting and to see these faces of the people working with such an enthusiasm on your demo case. I think it's fantastic. Thank you very much once again, Issam and Dimitri. And I will, if there are no other questions, I will collect the questions for you at the end. I know that Issam is on the way for another